So welcome students. In this question you're given a quadratic equation x square minus 2kx plus k square plus k minus 5 is equal to 0, and the both roots of this equation have to be less than 5. Then k belongs to which interval? So here this x square minus 2kx plus k square looks like x minus k whole square. So x minus k whole square is equal to 5 minus k, right? 5 minus k. This implies x minus k should be equal to plus or minus root of 5 minus k. So x is equal to k plus or minus root of 5 minus k. So these are the two roots of this equation, that is k plus root of 5 minus k and k minus root of 5 minus k. These are the two roots. Now these two roots have to be less than 5. So out of this, if you plot these two roots on a number line, we know that k minus root of 5 minus k is the lower root and k plus root of 5 minus k is the higher root. So if both roots have to be less than 5, obviously the higher root have to be less than 5. That is 5 has to lie somewhere on this side. So what is the condition which ensures that both roots are less than 5? The higher root is less than 5. That is k plus root of 5 minus k is less than 5. So this implies 5 minus k is less than root of 5 minus k is less than 5 minus k. And if you square it on both sides, 5 minus k is less than 25 plus k square minus 10k. This implies k square minus 9k plus 20 is greater than 0. That means k minus 4 into k minus 5 is greater than 0. So a quadratic expression greater than 0 implies k lies outside the roots. That is, k is either greater than 5 or k is less than 4. But obviously, as you see, if k is greater than 5, these roots are becoming imaginary. So for this, the discriminant, if you calculate the discriminant, it looks like something like 5 minus k. It will be related to 5 minus k. And so if k is greater than 5, the discriminant will be negative and the roots will not be defined. So if the roots should also be defined, k should be less than or equal to 5. So k should be less than or equal to 5. This is a condition for the roots to be real. And once the roots are real, if they have to be less than 5, k should satisfy this. So if you plot all these conditions on a real line, so you get k less than or equal to 5 as one root, one solution, and k greater than 5 or less than 4. That is, this is 4. So k has to be less than 4 and greater than 5. So if you take the intersection of these two roots, what is the common interval? So obviously you can see that k less than 4 is the required answer. So if k is less than 4, both roots will be less than 5. So k has to be less than 4. Thank you.